This presentation was given at the Oamaru Penguin Symposium in June 2021 in Oamaru, New Zealand. It summarizes the results of several satellite tracking studies conducted between 2016 and 2020 on Tawaki, which are also known as Fiordland penguins. The studies were a collaboration of the Tawaki Project, the New Zealand Penguin Initiative and the University of Otago, as well as the Antarctic Research Trust and the Global Penguin Society. Beyond the horizon, a closer look at the Tawaki winter dispersal. Tawaki are amongst the least known penguin species in the world. They belong in the group of crested penguins, of which there are 7 different species. New Zealand is home to 4 of these, 3 of which are endemic to the region. Tawaki is one of these endemic crested penguins. Compared to other crested penguin species like rockhopper penguins, Tawaki have a fairly limited breeding range. They nest along the remote southwestern coastlines of southern New Zealand, ranging from Bruce Bay in Westland all across Fiordland to the southern islands in the Foveaux Strait area. Although the Tawaki breeding range spans along a mere 600 kilometers as the crow flies, their habitat is nevertheless surprisingly diverse and can be divided into 3 discrete regions: the West Coast, Fiordland, and Southern Islands. The West Coast is characterized by a marine continental shelf habitat, with water depths ranging from 50 to 500 meters. Fiordland features virtually no shelf off the coast, so that penguins are foraging in pelagic conditions with water depths exceeding 1,000 meters. That is, unless the birds are foraging inside the extensive fjord systems. In the Foveaux Strait regions, Tawaki are breeding on Rakiura Stewart Island and several other islands with a marine habitat that is defined by its shallowness, with water depths not exceeding 50 meters. These differences in the marine habitat naturally reflect in the foraging behavior of breeding Tawaki. GPS tracking studies of chick-rearing Tawaki from Jackson Head West Coast revealed moderately long foraging ranges of an average 60 kilometers. In comparison, Tawaki breeding inside Milford Sound, the northernmost fjord of the Fiordland National Park, hardly ever left the fjord while raising young chicks, with foraging ranges seldom exceeding 3 or 4 kilometers. Tawaki from Whenua Ho in Foveaux Strait exhibited a mix of the foraging strategies observed on the west coast and in Fiordland, with many birds foraging close inshore around the island's coast, but sometimes travelling further away. But what happens outside the breeding season? After the chicks have fledged in late November or early December, adult Tawaki disappear for 8 to 10 weeks on journeys that prepare the birds for the annual molt in February and March the following year. Up until 2016, the IUCN Red List dispersal map of Tawaki seemed to suggest that the penguins had strayed over to Australia for a Christmas vacation. However, this distribution map was merely based on a few beach recoveries of some individuals. Clearly, there must be more to this story. In 2016, we traveled to remote Gorge River in Southwestland, an area known to be teeming with Tawaki. With the help of the West Coast Penguin Trust, we deployed satellite transmitters on Tawaki that were about to leave on their pre-molt journeys. The results were not at all what we expected. In preparation for the annual molt, it is imperative for penguins to pack on as much weight as possible in a relatively short time period. Fat reserves are essential for the birds to survive the 3 to 4 weeks of the molt, during which they cannot go to sea to feed and must fast while regrowing a full set of new feathers. Energy conservation should be imperative on these journeys. Given that December and January are highly productive months in the coastal waters around New Zealand, there should be plenty of food for the penguins. Instead, the birds travel to the cooler waters at the Subantarctic front, up to 2,500 kilometers away from the birds' breeding colonies. Some individuals covered close to 7,000 kilometers over the course of 8 weeks. It seems counterintuitive to run a marathon when you are trying to put on weight, but that is what the birds did. When we published a scientific paper summarizing the results of the study, it received a lot of attention by the media across the globe. Tawaki had officially earned the title of marathon penguins. In February and March, Tawaki returned to their breeding colonies to complete their annual molt. Once they have obtained a shiny new coat of feathers, the penguins disappear again on their winter travels, only to return for the next breeding season in August. While we now had a basic idea where Tawaki go before the molt, We were also interested if the birds traveled as far or even further over the winter. But more importantly, considering their diverse behavior during the breeding season, were penguins from different regions going in the same direction, or are they all heading their own way? Between 2018 and 2020, we used different tracking methods to follow Tawaki movements over the winter. In 2018, we deployed geolocators, devices that allow it to reconstruct the penguins' movements by estimating their geographic position using accurate sunrise and sunset times. In 2019 and 2020, we used once more satellite transmitters that provide more frequent and accurate position fixes using the Argos satellite network. In 2018, we deployed geolocators on birds from Jackson Head, West Coast, Milford Sound, Fiordland, and Foveaux Southern Islands. The devices were recovered after the penguins had returned to breed, and data downloaded provided us with the first winter dispersal data for the species. Birds from all sites traveled in the same general direction as during the pre-molt study, although without the added time constraint, the penguins moved even further away from their breeding colonies, covering distances of more than 10,000 kilometers over the course of 5 months. To investigate if this behavior remains consistent between the years, we repeated the study in 2019 with satellite transmitters. We deployed the tags on birds from the same sites as in the previous season, but also attached transmitters to 2 birds that had been taken into care at a rehabilitation facility on the east coast of the South Island. The results were pretty similar to the geolocator study in the previous season. The penguins all headed southwest to forage some 2,000 kilometers south of Australia, reaching distances of up to 3,500 kilometers from their breeding colonies and traveling more than 10,000 kilometers over their 5-month journeys. Based on the data from these studies, the distributional range of the species was updated on the IUCN Red List and now provides a much more accurate representation of where Tawaki occur. However, there was something odd about the data. The 2 penguins that completed their molt at a rehabilitation facility on the east coast seemed to head in a different direction compared to the birds that molted within the species' traditional breeding ranges. Was that due to both birds making landfall on the Otago coast to molt, or was this a result of them being cared for in a rehabilitation center, which includes getting fed during the molt, a luxury wild molters do not enjoy? To answer this question, we conducted a final satellite tracking study, this time comparing the winter movements of birds from Fiordland, our control group, with birds that molted on their own on the opposite coast of New Zealand South Island, the east coast, and penguins that molted in the care of rehabilitation centres. The results not only showed a bit more variation in the travelling directions, with birds from the east coast showing a tendency to remain further to the east while still travelling south, and penguins from rehabilitation apparently travelling faster than birds from the other 2 groups. These differences become more apparent if displayed as polygons drawn around the daily positions of the birds from each group. The comparison of the Fiordland and East Coast group shows very little overlap, especially during the first half of the winter dispersal, with Fiordland birds visiting ocean regions further west when compared to the East Coast counterparts. This changes somewhat when the penguins turn back to return to their breeding sites in May. But overall, it seems as if there's some segregation going on between penguins that molted on opposite sides of the South Island. Penguins that enjoyed full catering through the molt while in rehab literally outran the competition by traveling faster and further away, the furthest distance reached by a rehab bird being close to 5,000 kilometers. The bird in question covered more than 10,000 kilometers over the course of 5 months and was still approximately 1,000 kilometers away from the New Zealand mainland when its transmitter stopped working, presumably because the device had fallen off. From a statistical point of view, there was little difference in the dispersal behavior of penguins that molted unassisted on either side of the South Island, except for the easterly tendencies in East Coast birds, that is. However, penguins that molted in rehabilitation centers traveled further away than birds from the other groups and exhibited greater traveling speeds. This is most likely due to the significantly higher body mass of these birds at the end of the molt. While wild molters weighed between 2.2 and 3 kilograms, the rehabilitated birds weighed upwards of 3.2 kilograms and were almost double the weight when compared to their wild colleagues. The question is that a good thing? When we look at the average distance from the point of origin for each of the groups, we can see that penguins from Fiordland, green, and the east coast, yellow, kept traveling away from the mainland for about 50 days, after which they turned around to return to the mainland over the next 90 days. Rehabilitated birds, violet, kept going until day 60 or even 120, which put them at much greater distance to the mainland. This also meant that the rehabilitated birds were unlikely to return in time for the next breeding season. So it would appear that feeding Tawaki through the moult has the potential to disrupt their annual cycle significantly. In this light, feeding during rehabilitation should be kept to a minimum or left out altogether. After all, when wild moulters return to their colonies in July and August, they can hardly walk for the amount of body fat they accumulated over their winter journeys. Not bad at the end of a marathon run.